Good afternoon. Good afternoon, everyone, and welcome to MUSICX version 1.10 production release webinar session. So today, first, I would like to give you a brief information about the background of MUSICX, where we are up to, and our future plan. And then our urban hydrologist, Dr. Mukta Sokota, will provide a live model demonstration to explain the new feature. And then finally, we'll have a Q&A session that will be facilitated by our sales and support officer, James Norton. All right, so my name is Ashish Day. I'm the executive manager for eWater software product. Let me start with a very basic history of classical music. As you can see in this screen, so classic music was first released back in 2001 under the CRC for Casimir hydrology. And then gradually we released various versions of music. So last version 6, incorporated Music Link. And since then we had a few minor release, version 6.1, 2, and 6.3, and that's already several years ago. As you all know, there are some good things within music. CRC's extensive research knowledge is encapsulated within music. It is very simple, easy to use graphical interface, and it is a fit for purpose type of software. Dedicated treatment node covering almost all of the stormwater treatment infrastructure. Simplified treatment algorithm that is supported by extensive research, case studies, calibration, and validation. These are the good things that what we have in classic music, but there are some challenges. Main challenge is the code base. So the music classic is written in Fortran and Delphi. This is really backdated now. Many of the algorithm and parameters are hard-coded. Very difficult to add any new signs within the classic music. The number of pollutants are limited to 4, TSS, TP, TN, and gross pollutant. The rainfall runoff method, only one. Pollutant export method is only one. So these are the challenges. To overcome these challenges, we decided to completely rewrite the code base, but still maintaining the capability of classic music. So that is our MUSICX. The benefit what we'll be getting within the MUSICX is built on C#, which is modern and sustainable code base, upgraded technology and software framework, improved graphical interface, data manipulation, data import, export will be much easier. The graphics and graphics mechanism will be much simpler and advanced. Flexibility to add new feature and functions and new signs will be much easier within MUSICX. And also it will provide us the opportunity to build integrated water management model. When the plugin capability will be available within music, you would be able to adopt any new signs, any local needs through your own plugin. Rainfall runoff modeling options can be improved, can be added through plugin, and also wider range of pollutant also can be added through music plugin. So these are the benefits you can expect within MUSICX. Just to let you know where we are up to. So the first version of MUSICX was released back in 2020. All of the core function of classic music was incorporated at that time. The version was thoroughly tested and verified, and we are very satisfied with the MUSICX producing identical result of Music Classic. And then STS2, another version was released 2021. We incorporated Music Link at that time. All the user feedback we received through that 1 year, that has been also incorporated in STS2. And then STS3, which is something we're releasing now, is called version 1.10. There are a few new things coming in this version. some of the things I listed in this PowerPoint slide. As you can see, most important thing is this one, tabular model data editor. So now this is inbuilt within the music. So within that table, you can modify your data, update your data. You could even export this table into Excel file and then modify your data into Excel file and bring it in. When Mukta will be giving the demo, this is something she will be showing how to do this thing within MUSICX. The result manager has been improved. We added the link routing method, and summary report can be produced now out of MUSICX. The background image is now supported. Advanced modeling parameter, especially the case history parameter, now editable. Of course, there is a mechanism how to do it. Mukta will be showing you these things during the demo. And additional functionality also added, as you can see in here. Warmup simulation now available. Custom flow and pollutant import is available. Custom treatment within the media filtration also added. And also the online estimation of or inbuilt estimation of the inlet pond volume and stress for wetland and set basin node also added. So these are the few things that we added in this version. You will see the demo of all of this. And then S4, that is our ultimate goal. We don't have any time frame when we could do it, this S4 deliverable, but we'll try our best to do this thing as soon as possible. So ultimately, we would like to see music is fully integrated with source and urban developer. At this moment, integration is available, but it is not fully integrated. The advanced capabilities, new science will be added. I know there is a talk in the industry that whether music science need to be upgraded and so on. So yes, that is our ultimate goal. So we would like to upgrade the science as for new understanding and so on. But once we are applying with MUSICX with all this classic functionality, we'll be ready to add new science. As I said before, MUSICX is a platform that will allow us to add the new science easily. So additional pollutant, additional rainfall runoff method, additional treatment node, and the user plugin. That is all will come in ultimate version of music. I just wanted to show you two more slides. So this slide, you can see how the graphical interface looks like. If you have not seen MUSICX graphical interface before, just to let you know. Again, it looks like so many things here, but it is not complex at all. It is a flexible types of interface. Every single window is like you can dock it, undock it, you can hide it if you want to, but there are some key windows that you would like to keep within your music model building process at all time. This is the main things. This is one of the key things. Of course, you will be building your model within the main screen in here. And the left-hand side, you can see this is your node palette. You can drag and drop the node in here and connect them together to build your model. And here, right-hand side, this is your data source. As you know, in music, the climate data is handled differently, completely differently. Previously, in music, classic climate data was hard-coded inbuilt as a template within your project. But now you can have many climate data within your data source. You just need to assign what climate data to be used for a particular scenario or a particular project. So you could have 5 different types of climate data, but you're probably using only one with one scenario and another one with other scenario. And within your project, you could have multiple scenario. There is no limit as such. So you can have a main project, and within your project, you can have probably multiple scenario. And that scenario could be climate change scenario. It could be like a different configuration of wetland set basin or different configuration of your different types of treatment. So many scenario you can build. You just need to copy and paste. Mukta will be showing you how to build different scenarios. So these are the main key windows that you will keep it open because that is necessary to build your model. And there are a few other things. Of course, Mukta will be showing you how to see the result, how to see the log reporter, and a few other things. So this is the last slide I want to show at this stage. So this is the tabular data editor. That is the main thing we are at in this version. As you can see here, there will be list of different types of object, link, node, and within node, there are different types of nodes, source node, treatment node, and etc. So you can click on anywhere, and then you can see if you have, say, 20, 30, 50, whatever node in there, all node will be listed here. So you can edit data as a bulk edit using this tool. You can export this data directly to Excel, update this thing there, and you can bring it here. Your model will be automatically updated from that point. If you want to filter it, like if you have a very, very big model, you would like to see, okay, I want to see what the catchment area is bigger than, let's say, than 5 hectares. You can simply filter it by clicking this button here. So you can filter every single different parameter, and only that filter data will be visible within this screen. And also on the right-hand side here, you can have a quick view about all the database related to a particular object. You can see a particular object, and you can see everything in here. So that will give you the functionality to quick overview about your database, what is being used within the model. All right, so, and then, yes, you will see this thing in a live demo soon. I think that is all what I wanted to say at this moment. I now hand over to Mukta for a live demo. Over to you.
Thank you, Assis, and good afternoon, everyone. Let me first of all share my screen so that I can do a live demonstration. Starting from, I already do have music screen open here, and I have also created a scenario, as you can see. So, and then not only scenario, I do have also created some climate configured. So climate is already configured. You can see that in data sources. So just to give you an overview, first of all, so this is your music, and once you do have scenario created, you can see there are a couple of important windows here. One is this schematic editor, or you can call it modeling screen, where you can build your model that are using this nodes from this node palette, just using the node relevant to you. Another one is this project hierarchy or project explorer, where you can see your project and also all the scenarios within that project. And this next one is node palette. So you can see here all the relevant node palettes, which can be used to represent your device, catchment, and the receiving water bodies. So this is node palette. And the last one is data sources, which is again very important. And you can have all your climate data, which are configured within the music for running, and you can have extra data as well. And also you can have some reuse data or any other time series data that might be useful when you are building your model. So all of them will be here. Now I'll start first of all by showcasing Tabular editor. We call it as a feature table within MUSICX. So let me first of all show you how this works actually. So for that one, what I'm going to do is I have already created a scenario. So I will just create a model within this scenario. So we'll try to build something, starting from bringing one source node here. So to bring any nodes within the schematic editor or modeling screen, what you have to do is select the node, drag and drop onto your screen. So you can see now I do have my source node ready here. And for this case, as I want to show you how you can multi-edit, I'm going to bring similar type of nodes here. So I'm just bringing a couple of source nodes, and then also I'm going to use a couple of biotension. As I want to show you how Tabular editor works, I'm going to use similar type of devices here, and maybe another type of device here, so that I can show you later on how these are actually accumulated within a feature table. Now also using some set basin. Finally, let's say this goes from wetland to receiving node. So in this way, I have all my nodes ready. I also need to connect upstream node to downstream nodes. So for example, to do that, what you have to do is once you go to your upstream node, you can see some blue box there. And once you click on that blue box, you can see all the other downstream nodes which you can connect to. In this case, I'm connecting this to this a particular biotension. So this is how you can connect your link. Let me do that for all of them. And then from here to here, again, this is going here, just creating something so that I can show you how this feature table works. So As you can see, I have just created one simple model here. Now, as I said, like, let's see, I just built a model, but I haven't configured any of the properties for these nodes. And let's see how you can configure. So if you click on this source node, whether you can right click edit or double click on it, then you can clearly see, like, there are a lot of parameters for this one, which you can go and type, okay, this is like, for example, this one here is 9 hectare, this is 90%, so just assuming something here. And now you have to change all these parameters. Not only that, you have also need to change like the other parameters here, like how contaminants are generated from different type of flows, and again for different contaminants. And you can definitely do it here, but sometimes when you are dealing with a very large model, it might be not very efficient to do in this way. So what you'd like to do that time is, like, you want to have some tabular editors which will allow you to do a quick comparison or edit the parameters between similar type of nodes. And you can do that using your feature table. So let me show you the feature table here. To bring your feature table in, what you have to do is go to click here. You can see here, edit. Under edit, there is this feature table. So once you go to edit, click on feature table, this will come up with this screen here. And left-hand side, you can see this shows all the relevant links and nodes that are like relevant to your model here. So you can see, if you click on bioretention, then you can see I have got 3 bioretention here. Or if you go to source node, for example, you can see, okay, these are the source nodes here, and all the source node listed. You can also, if you click on source 1 and see the properties for that particular one, you can see here, it gives you also all the related properties for that particular node as well. You can now go and edit the properties here. For example, okay, I want to have this as a 7, 11, 5, and 4, for example. So I can edit it here or compare it here. I can also filter it. Sometimes, like, I want to look at some range of the parameters. Let's say, like, for this, I want to filter it based on the total area. So let me go here. So what I want to see is, I want to see something which are greater than 4. Yeah, so first of all, you have to click that on. So, okay, greater than, for example, greater or equal 5, and then less than, let's say, 10. So I just put the range here and filter it. Now you can see here, this is filtered only based on that criteria. I can, if I don't need that filter, I can go here and reset that filter as well. So this is how you can reset it, edit it. Next one is, when you have you might have sometimes like 30, 50 source nodes, and again, editing here itself might be not as handy as doing that in Excel. So in that case, you can now export these data as Excel files. So let me do that now. So let me export this, and I'm giving this as a, let's say, source nodes, and I'm just saving this file first of all. And let me go to the folder where I saved this one. So this is this one which I just saved. So I'm just opening this now. So what I can do is, I can now open this one, and let's say I want to change some of the properties, like this one here. And just like, okay, this is the same. And then for this one, I want to use 30, for example. And okay, this is 110. This is 210. So I'm just changing some of the parameters here. And once I changed all these parameters based on my requirement, as you can see, there are a couple of parameters, I can save this. And now I'm going to close this file. So going back to my screen here itself. And now here I can see, I can import the same file which I just changed. So this is the one, source nodes. I'm clicking open. So you can now see how these information here are changed. So you can see here, I have like, changed this sort of information here. So this is already reflected here, and working in Excel will be like, far efficient compared to when you do that within a node and so on. So this is something will be available in our new feature. All right, so this is about feature table. Now, next one I'd like to show you is this warm-up simulation. So let me show you how you go to the warm-up simulation. So you have to click on configure for warm-up simulation. And first of all, what is warm-up simulation? This is like, sometimes you want to have like, initial properties, especially for source node. There will be some initial storages for your pervious area plus groundwater. So if you want to have that set up from the model, then you can have run up simulation. And for that one, what you can do is there is this tab here, run with warm-up. So if I unclick it, it won't do that. But if I click run with warm-up, what it does is it will pre-run this model for 12 months and then set those initial values for your source nodes and rerun the model for whole time period. So that's how this warm-up simulation works, and that is now available within MUSICX. So this is about warm-up simulation. Now I'm going to next one, that is routing. Usually for music, as you all know, we don't use routing as much, but there might be sometimes when you need to use routing, and this is now available within MUSICX, and I'm going to show you how you configure for routing. And I'm going to use this example here, this link. So I can right click and edit the link, or just double clicking. If I right click on that link and click edit, then you can see there are like, routing options available. One is no routing, which is a standard music one. But if you need to do routing, then we do have Muskingum routing available, which is similar to Music 6.3, but more advanced. You can not only do linear routing as in Music 6.3, but also non-linear routing is possible within this one. So let me show you one example. So I'm just using here, changing some parameters, this storage constant, which is basically your lag time definition, especially if you are considering the linear routing. So I'm just using 360 seconds for example. This storage exponent, I'm assuming linear. If it is non-linear, then it might be less than 1, but I'm just using 1, making it linear. And inflow bias for this example, I'm using 0.25. So now I can click OK. Now I want to have a look like how this parameterization is attenuating my flow. So to do that, I also want to record some of the parameters here. So I'm going to this default link here to record some of the other data. So what I want to see here is what was the inflow for this link and what was the total runoff generated. So after that iteration, so I'm just recording that in and out for this link. So I did that. Before running model, I'm also interested to look at a few other things. So I'm also recording a few other things, which I'm going to explain to you after some time. So let me now run this model. So now, as you see, what it does is it applies that Muskingum storage routing for this default link 1, and it will now attenuate the flow based on what sort of parameters I have actually recorded. And based on those results, I can now go to Results Manager and look at like what sort of inflow was coming from here and what happens when it goes into bioretention in this particular case, how like in after attenuation, what sort of flow is going. Once this model run finishes, the results will be results by default, like opening on Results Manager. If somehow that is not opening, you can just close your simulation, this window here, and go to View and click on Results Manager. Also, function F10 is going to open the same screen. And as I said, like once that is open, we can see the results. Also, together with those inflow outflow, I also recorded a few other things such as cumulative frequency graph, which I'm going to explain in a bit after this simulation finishes. So let's see, seems like it's going to finish in few seconds. So let's see what's happening here. Yep, so finished now. So once the run finishes, as you can see, results manager open automatically. Now you can go to latest run, and as you can see here, like all of these are in alphabetical order for you to easily find out where exactly the data is. So I'm going to music routing, and within default link 1 where I applied my attenuation. So I'm just putting flow. That was what was going in, and this is my outflow, which I can see on the same screen as you can see. So this is showing you like, okay, this red line here was your inflow, and then after that routing applied, then this is like this blue line, what was going as outflow. I can also look at like some of the parameters here. So let me just zoom on only one axis, and let me just see some of the parameters actually here. So I'm just maybe this one here. So let me show you. So you can see, if you see individual things, how like, this is attenuated and this is flowing over time. So that's how this overall routing is working here. So this is now available. And for lagged routing, I'll just quickly show you that one as well when I'm here. So if you want to define lag routing only, which is like, not providing this inflow bias, in that case, what you can do is this inflow bias, you can put it as 1. So that will give you that lag routing option, which used to be available in your MUSIC 6.3. So now let's go back to results manager. As I said, like I also wanted to show you this cumulative frequency plot as well. So what it does is, let me first of all go to this cumulative frequency. So I'm going to this receiving node and clicking on flow-based cumulative frequency graph. So sometimes you need to get some of the information on, for example, there are some compliance from the authorities, like your flow should have 90% of the time total nitrogen concentration should be less than that. And in those cases, you might need to do this cumulative frequency graph. So if you see here, for example, so I'm just clicking on total nitrogen, you can see, but let me also see what's value. So for example, you can see here, 65% of the time, your total nitrogen is less than 1.5. So this is like, sometimes, as I mentioned, some of the authorities you have to follow that compliance based on the guidelines and make sure you are getting this sort of thing. Now, again, there might be certain scenarios when you want to have a look at these different contaminants within certain flow range. So you want to exclude very low flows and also very high flows, and then just see the results. So in that case, what you can do is you can apply lower flow threshold and upper flow threshold. If you click on lower flow threshold, and what it does is it will just include the values greater than the values you are using here. If you click on upper flow threshold, what it does is it will include only values which are less than whatever value you are using. And a lot of times, a lot of authorities has certain compliance that you should not be including these zero flows when you are actually calculating this cumulative frequency graph. So in that case, what you have to do is you have to click on lower flow threshold, and okay, this is the flow. I just want to exclude all the zero flows. So I just put, okay, this one, and apply filter. So once I do that, now you can see here for the same, like, 65% now you have got your nitrogen less than 1.6, something like that. So in this way, you can actually have a look at this graph. And as I said, you definitely need to record this before you run the model, if that is a requirement. And you can, this is available at any nodes. So you have to go to that particular nodes where you want to view your flow-based cumulative frequency graph and need to record it for viewing it. All right. So now after this one, next thing I want to show you is summary report generation. So what summary report generation does is it generates a file that provides a treatment summary, as well as it also give you all the values or parameters used within your model, so that someone can summarize it. There are certain authorities who uses this summary report for some post-processing analysis. Especially, I know in Melbourne, that is something most of people uses summary report for doing some post-process analysis. And now I'm going to show you how you generate summary report within MUSICX. So to generate summary report, what you have to do is, before running the model, you need to go and click on Edit Scenario Options. Once you click on Edit and Scenario Options, you can see here there is this MUSICX summary export settings. I have already saved it. So what you have to do is you have to first of all auto export and run. I already run the model, so before that I just did that. And you have to also define the directory. For me, I have actually saved this in this folder. So this is already there. And you can also put run number, date and time, if that is easy for you to follow later on. For the format, there are a couple of formats, .mrt.txt. Whatever format you choose, you can open these files within text editor. And also you can bring those files in Excel as well if you need to do some post-process analysis and so on. So that is the way how you actually generate your summary report. And as I said, I already had that on earlier. So when I run this model, this also generated a summary report, and I'm now going to show you how this summary report looked like. So this is the one which I just created a few minutes back when I run model. So now let me show you the format, so I can just edit with Notepad+ here. You can see it shows me all of these nodes and all the values what has been used for different source node, treatment nodes, and it also gives me some summary, statistical summary as well, which I can see some results there. So this is the summary report generation capability, which is available now. So let me now go to the next one here. So now next one I'd like to showcase is, as Ashish mentioned earlier, background image is supported within this version of MUSICX, and I'm going to show you that how you bring your background image if you need to do so. So first of all, you definitely need to create a scenario. So I'm going to create one scenario here. So for creating a scenario, you can just simply go here under File, there is this New Scenario tab, or also if you go to File, New Scenario, you can create any scenario. So I just create scenario, and there are a couple of options as you can see. Muskingum Link is for those councils or authorities who have got their water-sensitive urban design guidelines, music guidelines embedded within music. This is MSF importer option for bringing your old music classic files to MUSICX, and the normal one, what you build is using this MUSICX. So I'm just using this MUSICX option and clicking OK. So once I do that, so now let me open that one here. So this is where I can say, if you go on the interface, there is this set background image option here. So I'm going to click set background image and just bringing one background image here. So you can see here, this is your background image. You can also actually show or delete or hide background image. So let me show you here. So I want to hide background image. I can just click, then no more background image here, or I can again bring it back. So, or delete it if I don't need it. So I'm bringing it back, clicking on show background image. So this is how background image works. And once you have your background image, you can bring any nodes that are relevant for you and then start building your model. This is all about background image. Next one, I like to show you some other features, like there might be the situations when you want to use your own flow or both flow and contaminants when you do have non-standard type of flow or like, contaminants and so on. So that's what I'm going to show you. Again, I'm going to create a new scenario for this one. So let me go and create a new scenario from here. Just under file, there's new scenario tab. And again, some standard MUSICX scenario I'm creating. Now, what I'm going to do is bring source node here. And first of all, I want to show you an example where you are going to use runoff from outside music, but is still using the contaminant generated from the music. So to do that, this is now available within source node itself. So if you click on source node, you can see here there is this option, custom flow and generate constituents. So what it does is you have to provide the flows, and based on the flows, your flows you are getting from outside music, it will now generate the constituents based on music modeling itself. So let's also do this example. So you can provide your area, pervious, impervious percentage as well. And then you also need to define this different flows. So you need to have these flows provided here. Let me bring some flow data here. So from data source and file data source here, I do have some flow here. And this has got all type of flow, base flow, impervious system flow, pervious system flow. You also need to make sure these units are correct, which are already correct here. So I'm clicking OK, and I'm assigning first of all base flow. And now I'm going to click OK. Next one is impervious flow. I already have data source within the same file. So I'm just doing that as well, clicking OK. And finally, I'm bringing pervious flow as well. So this is my pervious flow. And now you can see all of the flows are done, and I can click OK. So this is how you can actually set up the node when you do have your own flow, but want to still generate constituents based on your music. Next one I would like to show you is the situations when you might have, for example, some non-standard flows, like some CS flow is mixing up, coming from somewhere, and that is definitely not going to be as your system flow. It will have a very, very different sort of contaminant generated. So in that case, what you can do is, again, let's bring this source node here itself. Yeah. And now you can just double click or right click edit to, and there is this option here, custom flow and constituents option, where you can define your flow and contaminants, everything for those sort of like, non-standard situations. So let me bring this data. So I have to bring that data now, so from file data source. So this is like where I do have my both flow and contaminants. And this is, I have to select the unit. So this is kg for time step. So I'm just giving it. Other units looks okay. So now, first of all, inflow, okay. Then total suspended solid. I have this in this file already. So just again clicking. Now this is total nitrogen. So I do have my total nitrogen here. And hormone is my phosphorus here. So I'm also giving value for phosphorus. And then finally this contaminants here. And for this one, this is cross-protein. So, okay. So you can see here, that is how you can just include any non-standard type of flow within MUSICX. Now I'm also going to show you a few other things. So for that one, I'm bringing some extra nodes here. Let's say there is media filtration here, set basin and wetland, and then finally going to some receiving node. I'm not doing anything else here. And from here to here. And you might have noticed, like, in earlier my scenario, it was coming as a straight line, but as an elbow now. So how you change that is like, you do have an option here. So making it a straight line, or just like, want to see as an elbow, it's up to you. And also this is something like, if you don't want to see some of the name, you can just change it as well. So I just did it this way. Now, before running this model, what I need is I need to configure the climate data as well. So I'm now going to show you that configuration as well. So starting from, you need to click configure here. And you don't need to have metrological that MLB files for running music model anymore. You can have any type of data like CSV or AD data. And you can also run the scenario with one data set once and again change that one, and then like it is not locked anymore. You can bring other data set and again read on it with that data set as well, unlike what used to be in Music 6.3. So for that one, I'm going to choose this custom climate data. And first of all, I'm going to bring rainfall from again data sources. So I do have some data within the same file. So I'm using this Brisbane rainfall here, and also assigning the unit and clicking OK and choosing the rainfall. So that's how I assign my rainfall now. And for PET, I'm using monthly pattern, and most of the time it is good enough to use monthly data. So I do have some monthly pattern as well. So I'm just using this Brisbane monthly aerial PET here and clicking OK. So in this way, you can see I have set up the climate data as well very quickly. Now, once done, I can simply run this model. If I want to record some other things, I can go, especially by default statistics, all the statistics like treatment run effectiveness, mean annual load, those sort of things will be recorded. But if you want to record anything else, like, the time series of flow contaminants, you need to record them before running. So you can see here, this already finishes running, and you can see trend effectiveness you are getting from this model is something like that. So in this way, you can utilize this custom flow and custom flow plus contaminants. You can model in this way. Finally, before finishing this one, I would like to show you a few other things. So if I now click on this media filtration, for example, and now go to advanced here, you can see these are not editable. Yeah. And usually we recommend not to touch these parameters as well. So don't touch it unless you are doing something else, because calibrating and balancing the parameters are not easy. And whatever value we have got here is from a lot of research. But anyway, if there is a situation when you have to edit these parameters, you can do so. So how you can do it, I'm going to show you. So to do so, what you have to do is you have to go to edit and go to project options. Within project options, you can see this is MUSICX treatment node settings, and you have to click it as editable. So once you click it at editable and click OK, now let's go back to this media filtration. So you can see you can have you can change these values according to your need. You can also change this customized treatment parameters. So these are again based on certain analysis. So you can also change these parameters once you make it editable. So that is now possible within this version of MUSICX. Next one we do have available is, let me show you sedimentation basin. So for sedimentation basin, you can now estimate parameters by giving other parameters here. So these equations, especially sometimes very hard to do manually, but that is now within MUSICX. So you can provide what sort of sediment you want to remove using this one. And also you can decide what is the contributing catchment area, design flow, sediment loading rate, capture efficiency, cleanout frequency, and all those parameters. And based on that, it will estimate your size of sedimentation basin. And similarly for wetland, this is available. So for wetland also same principle here. And based on the same principle, it will just determine your this inlet pond volume for your this wetland as well. So again, based on the same properties as I mentioned, same properties, yeah, very similar. And then based on that, it will just define your inlet pond volume. So that is also available. So I think that is all from me. Now over to you, Assis.
Thanks, Mukta. I'll just thanks for the presentation. And yeah, did you want to say something, Kashish?
Just 1 second. No, thanks, James. Definitely, we are going to Q&A session that will be facilitated by James very soon. But before we go to that Q&A session, I just wanted to highlight And the licensing and turning option, what we have available right now. So MUSICX is already available, as you know, so anybody can get it from our toolkit. But the version 1.10, which we are demoing now, will be available from tomorrow. So anybody got a current SMA up to date, they will be able to download this thing and use it free of cost. The turning option, we are really running two different types of turning option. One is transitioning course from MUSIC6 to MUSICX. Another one is the full MUSICX training course. So feel free to participate. 50% of the training fee will carry it back to any new license process within 6 months. For Music Classic 6.3, we're continuing it. Existing user can continue to use it. We'll still provide support, but the product and services will be discontinued in future. If you have any question, of course, the contact detail is in there. Feel free to contact us at any time. So that's all, James, I wanted to talk. So now we can run the Q&A session.
No worries. Thank you, Ashish. All right. So we had a couple of questions come through whilst you're doing the demonstration, Mukta. So the first one was from Oster. Can we adjust the warm-up period?
Thank you, Oscar. Warm-up period is not adjustable at the moment. It will be like, first of all, running for 12 months, and based on that, it will use that as an initial value and read on the model for the whole time period, but it won't adjust, can't adjust the warm-up period as such.
Okay, thank you, Mukta. And the second question we got here is from Prabin. In the data sources, the rainfall data is taken from the BOM website. Can we increase or decrease the rainfall data by any factor such as 0.9, 1.1, 0.8, 1.2, etc., to see the effect of the increment or decrement of the rainfall? And in addition to that, he's also added, from my query above, I think if I edit the rainfall data in the spreadsheet, I can use the edit version of the rainfall data to see the effect of the rainfall. Am I right, or is there another way to get the results? From one click, maybe?
Yeah, so I can take that on. You already mentioned like how you have to do it. Yes, you can edit your rainfall data outside in Excel or a spreadsheet, and then can bring back that in. But the good thing is you can have two different files there, and two scenarios there with different rainfall data, and there is an easy way to compare it. So within Music, as you can see, Results Manager, not only you can compare within a scenario, but also between two different scenarios, and in that way you can compare the results between two scenarios after you bring those data in.
Okay, thank you, Mukta. We've also had a few comments come in. The format from Adrian Cox, the format of the import CSV files are other examples available.
For format of import, if it is for PET, we already do have some PET data in CSV format within made data folder inside MUSICX software where you are installing. If you are installing, for example, in C drive, then if you go to those C drive program files under eWater, there is this made data and some climate data there, and there are a couple of PET files which are in CSV format for monthly pattern. For other format also, if you need any sort of 6-minute data format as a CSV file, you can email us to our support email and we can send you the format as well.
No worries. And Paul has written in, will a copy of this presentation be made available? It would be good to listen to it again for a refresher down the track, especially given some of the functions are not commonly used. We probably put this on the YouTube channel, maybe, I think.
Yeah, that's right. So this session is recorded. Of course, we'll be sharing this thing with the participant.
Yeah, so yes, it will be. Kayani has also wrote in, and she's wrote, what would be the process to generate a flux file similar to that of version 6.3 for a treatment node, say for a wetland?
I can take that, James. So Thank you for the question, Gani. For flux file, so in MUSICX, it's much more flexible. Actually, you don't have to record everything for a single node like how flux file used to be. You can just go and record what you need. And for wetland, for example, if you need water level, usually I think for Melbourne wetland, water level is used for fluorination analysis. You can just record that and then use that for your post-processing or some other things what you are going to use. So you can just go and record it and then can just export that as Excel file as well. I can quickly show you maybe just like, that, just let me, you are on that screen. So I'm going to just share my screen, all right?
Sure, Mukta. Is there any other question? Just pending question, a lot of questions.
Resource manager, so.
No, there's one more question from Jen. And if anyone else wants to write any more questions in or raise their hand, we can.
Other
data here, which I recorded, for example. So if you go and, for example, like it might be water level, like, in your case for wetland. So if you have this one, you can go to table here and now export this, just or open that in Excel. So in this way, you can just export what you need. Also, if you don't want to actually export that in a 6-minute format, for example, you can just say, okay, I don't need 6 minutes. I want to aggregate it in a daily basis. And so now if you go to the table, this is daily now. So now you can export this as a daily file if that is your requirement. So all those options are available. Over to you, James.
Okay, thanks, Mukta. So we've got one more question from Jim. Does the link change the display such as a dot color in the different routing types?
Not at Jim.
Okay, so that's not yet. Thanks. And we have one more from Dale. Dale Brown, great process. Good to see the summary report and advanced properties now supported. Will command line run be supported for calibrating music to field monitoring data? Also, is rainfall data at other time steps, e.g. 5 or 10 minutes supported?
I can talk about that. And thanks, Dale. Very good question. Yes, that is the future. Command line running will be available, and also we have a bigger plan actually separating the engine from interface. At this moment, of course, this is not really supported as such, but in future, yes.
Okay,
and there was another question, 5 minutes and 10 minutes data. You can run it now as well. Even 1 minute time step, you can run it.
Yep. Okay, thanks, Mukta. That's all the questions that we've got written in. If anyone else wants to ask any questions, we've still got a few minutes to go. Yep, we got great webinar. Thank you from Banya for you. Thank you. Just wait a second, see if any other questions come in. Otherwise, we might wrap it up.
Yep, sure. And again, if you don't have question now, of course, you can ask us later. We strongly recommend everyone, please download the software tomorrow. We'll make sure this is available by tonight. Please download and use it. And if you have question, feel free to contact us at any time.
Yeah, that's right. Thanks, Ashish. Yeah, we haven't got any more questions through. So did you want to leave it there?
No, that's it. And thank you, everyone. Again, I appreciate your time. And yeah, I think that is all. And we'll be in touch and enjoy new version of MUSICX. And thank you, everyone.
Yeah, thanks, Ashish.
Thank you.
Thank you, everyone.
Bye.